Problem number 3. Step 1 is to isolate the log. Now remember, the log in its entirety is the word log, the base of x in this case, and the argument of 81. So this is our log. Right now, it is not isolated. It is not all by itself. We still have that 3 out in front. Right now, the 3 is being multiplied to the log. Because there is no operation, there is no symbol between the 3 and the log, I know it has to be multiplication. So opposite operation of multiplication is division. I divide both sides by 3. And the 3's cancel out to be 1. So on the left, I have log base x of 81 is equal to 6 divided by 3 is 2. Now that my log is isolated, I now look to get rid of the log. Opposite operation of log is exponential, meaning I have to exponentiate both sides, create that big base. I use the exact same base as the log, so the log has a base of x, so I use a big base of x on both sides. X raised, this is all in the exponent now. So x raised to the log base x cancels to be 1. And on the left, you're left with just 81. Is equal to x raised to the power of 2. Now this is extremely similar to one of the examples I did previously. This is a quadratic, so either I can move everything to one side and put it in standard form and look to factor, or I can remember, okay, when there's no b value, what you do is you square root both sides. Because how do we get something unsquared? Opposite operation of squaring is square root. So you square root both sides, and the square and the square root cancel, leaving you with just x. Now the square root of 81 is not only the positive 9, but also negative 9. Both positive 9 and negative 9 multiply to give you a positive 81, right? 9 times 9 is 81, and negative 9 times negative 9 is 81. So we have two solutions here, and we must check both. I'm going to plug both negative 9 and positive 9 into my original x and see if they work. So I have 3 times log base 9 of 81 is equal to 6. And I also must check the other solution of 3 times log base negative 9 of 81 is equal to 6. So I'll do the positive 9 first. I must evaluate this log. My argument is already one term, so I can just, boom, go ahead and evaluate it. You ask yourself, what power do you raise 9 to equal 81? You raise 9 to the power of 2 to equal 81. So this evaluates to be 2. And you just bring down the rest of this equation. 3 times 2 is equal to 6. You just brought it down. So 3 times 2 is 6. Set equal. The right hand side is also 6. Both sides are 6, meaning our solution of 9 is valid. Now let's go over here and check the negative 9 solution. We have log base negative 9 of 81 that we must evaluate. Now this should be a stopping moment, because we remember that we can never have a negative or a 0 as the base or argument of a log. So right now this negative 9 here in our base cannot happen, meaning this negative 9 solution does not exist. It is extraneous. This is exactly why we check our answers, because here the only solution that can be circled is positive 9.